All right, grade 11s, we're on days 8 and 9, and I'm putting these two together. So this one will be quite long. So if you only get through a little bit tonight and then a little bit more tomorrow night, that's just fine, because we need to take some time to put all of our different transformations together. So let's come up with a summary sheet. We've done a lot of things. We started with translations, which are simple movements left, right, up, or down. So if we have a vertical change, we have a function, and we have added to the end of it. Outside of the function is a vertical change. If k is positive, or you've added something, your change is up. If k is negative, or it looks like you're subtracting something, your translation is down, vertical changes. For horizontal, if we have a function and we have added or subtracted to it, inside the function, then we have moved our function left or right. If we have f of x plus a number, it's backwards to what you would think your movement is left. If it's x minus something, or x plus a negative number, your movement is right, backwards to what you might think. Forget our horizontal is interesting. For reflections, if we are reflecting vertically, we are reflecting things from up to down. So we have a reflection across or in the x-axis. Ups to downs, helps my brain. So if we have a reflection in the x-axis, our function has a negative in front of the parent function that we're used to seeing. All of the x-intercepts would be invariant points. A horizontal reflection would be a reflection in the y-axis, and things would be reflected across the y-axis, rights or lefts, lefts to rights. My function would look like a negative side of the function. Our stretches and compressions were probably the most difficult. An expansion is a stretch. Expansion, stretch factor greater than 1. Compression is also technically a stretch with factor less than 1. Greater than 0, because our negatives would be the reflections that we've already dealt with. A vertical expansion or compression is when we multiply our function by a number. I'm going to call it k. So because that number that I'm multiplying by is outside of the function, it's a vertical change. If k is greater than 1, I have a vertical expansion. Grab your function and pull it up. Sorry, there's a 1 right there. If your stretch factor is between 0 and 1, so it's a fraction, you have a vertical compression factor, whatever that fraction is. For horizontal expansions and compressions, we have multiplied inside the function. And this is where it's strange. If k is a number larger than 1, then there is a horizontal compression factor 1 over k. So if you had a function with 2x inside the function, it would be a horizontal compression factor 1/2. Sorry, don't need that. If our multiplication factor is a fraction, inside of the function, opposite to what you would think, is a horizontal expansion. Also factor 1 over k. You flip that fraction and your number is large for a horizontal expansion. In summary, if we put it all together in one great big equation with f being our function name, so no matter which one of the parent functions is or any other function, as long as it's a function, these various constants change our function with various transformations. The number at the very front and at the very back, since they are outside of the function, would be vertical changes. The one at the front, a, since I am multiplying, is going to be a stretch. And depending on whether it's larger than 1 or a fraction, will tell me whether it's an expansion or a compression. The k at the end is a transformation because I am adding on. So if I am adding, I am moving up. If I'm adding a negative, I am moving down. Sorry, translation. I can't spell. The two within the function, the b and the h, because they're inside of the square brackets, would be horizontal changes. When we add on, it is a translation, but it's horizontally when it's inside the function. This is a horizontal stretch when you multiply for b, and the size of these various constants will tell us whether it's left, right, up, down, thin, or wide. Let's just summarize it on this sheet as well. If a is larger than 1, we have an expansion. If a is between 0 and 1, we have a compression. I'm doing the next stretch, the horizontal stretch where things are backwards. If b is greater than 1, it's a compression. If b is between 0 and 1, or it's a fraction, it's an expansion. If h is positive, we are adding a positive, it's backwards, it's left. If h, we're adding a negative, it will be a move to the right. For k, if k is positive, we are adding, we are going to move up. If k is negative, we move down. If I have some function y equals f at x, and it has been transformed to, we have done both horizontal and vertical translations only. We want to determine the values of h and k for each of these specific transformations. They're only translations in this question. So first of all, we want 3 units up. That is a vertical change. So we are outside of the function. And if we want it up, we have a translation. We're going to take our old function and we are going to add 3 so that it moves up. 5 units to the right. That is a horizontal translation, so it's going to be within the function. So we will take our function, we're going to do something inside of it. If it's to the right, it would be subtract 5 when it's horizontal. The third one has a little bit of each. We have our function, and we want our horizontal, and we have our vertical, and we want to put it into the equation. So the 2 units to the left is within the function, and the 4 units down is outside. Subtract 4 on the end. If we want 2 units to the left, we are going to have x plus 2 for our change. We're going to describe using transformations and writing the new equation where appropriate. So for the first one, we started with a function called f, and its name is quadratic x squared. Our new function with name g of x is also a quadratic, but it has some transformations. If I take f at x and go 4 to the left and down 1, I have my new function. B is the square root of x function. If I want to transform f at x to g at x, I have to take my old function and again move it 4 to the left and again down 1. For the third one, I have a square root of x function. You can tell this smartboard doesn't like that function. And I am transforming it to g of x, which is 2f at 3x. So my first, I'm always reading left to right, my first one is outside of the function. It is a vertical, and because it's multiplying, it is a stretch. Since that number is larger than 1, it is a vertical expansion, factor 2. So I grab my old function and pull it up twice as fast. And the 3 is within the function. It is a horizontal. I have to decide whether it's an expansion or a compression. It's a compression because it's larger than 1. Horizontal compression. Factor 1/3. A new equation where applicable would be g of x equals 2 times the function. Well, I can start. My function is square root, and inside the function, I want to put 3x. There is my new function. D. I'm starting with a quadratic again, and I have my equation already done. I just need to list and describe the transformations. Left to right. I have a number multiplying outside the function. It is a vertical. Since it's a fraction, it's a compression. Factor 1/2. So if I were drawing this parabola, my step pattern, all the ups are halved. Over 1 up 1/2, over 2 up 2, and so on. The next thing in order I have is x plus 4 inside the function, so it's going to be a horizontal translation 4 to the left. Lastly, I have to subtract 5 on the outside of the function, so that will be a vertical translation 5 down. E, my parent function is the square root function. I am transforming the parent function to g of x, which is 2 times f at x. Inside the brackets is minus x minus 3, and then a plus 4 on the end. My 2 easiest ones are the ones on the outside, 2 and the 4. The inside is a little bit trickier. I'm going to do this in different order. I'm going to rewrite my function using function notation. G of x equals the 2 and the plus 4 are outside of the function. The function itself is the square root function, and inside my function would be minus x minus 3. I know that's not how I want to see my function. For horizontal translations, I always want to have x plus a number, not negative x plus a number. So I'm going to change that by putting my negative sign outside, factor out the negative, and rewrite it like that. Now I have what I am used to seeing. X plus a number tells me whether it's a left or a right shift. Now I've got my 4 possible functions. Let's do it in order from left to right. 2 is a vertical stretch. It's an expansion because it's larger than 1. Vertical expansion factor 2. In order, the next thing that I see within the function is a negative sign. So because it's inside, it's a horizontal. Because it's a negative, it's a reflection. And just for sake of interest, if it's a horizontal reflection, it's a reflection in the y-axis. My lefts are rights and my rights are lefts for horizontal change. The 3 is also a horizontal thing because it's inside the function. It's a translation, and it's 3 to the left. Lastly, my add 4 on the end, outside of the function, is a vertical change. It's a translation, up 4. Lastly, f at x equals x squared. We're working at it with a quadratic again, and we are making some changes. We have 1, 2, 3, 4 different things going on. I'm going to list them left to right because that's the easiest way when we sketch them. The first thing that I see is a negative sign. Out of the front means a vertical change. Vertical, a negative means reflection. If I am reflecting something vertically, it's ups to downs, downs to ups. I'm reflecting on an over the x-axis. The 2 is within the function, so it's a horizontal change. It's going to be a compression. Factor 1/2. Subtract 5 is next. X subtract 5. And I have it the way I want it, like I did in the question above as well. I've got x take away a number, not negative x or anything like that. X take away 5 means it's horizontal. Translation, because we're adding or subtracting. And it's to the right, 5. Lastly, I have add 6 on the end, so it's a vertical. Translation, when we add, and because it's vertical, it is as you think, it's up 6. We're going to draw some together. I'm having trouble getting the smartboard to make them really pretty, so I'm going to do the best that I can. We're going to start with our parent function, y equals x squared, which is a parabola. That rather roughly is the parabola y equals x squared. I want to draw the transformed function y equals half x plus 4 squared minus 5. I know you know what this looks like because you've done it in grade 10, but we're going to do it as a series of transformations. That means one step at a time. We are going to work from left to right. So the next thing that I'm going to draw is y equals a half f at x, or y equals a half x squared. That is a vertical compression factor 1/2. That means all my ups are halved. So starting at 0, 0, because I haven't moved it left or right, I move over 1 up a half instead of 1. Over 2 up 2 instead of 4. Over 3 up 4.5 instead of 9. Everything is halved vertically. That roughly, in blue, is y equals a half x squared. I honestly suggest you take a minute and try and draw them yourselves. The second thing that I see is x plus 4 squared. So we've got the plus 4. So my second transformation is to take your function and move it to the left or right, 4. And that is a horizontal translation, 4 to the left. So I'm going to take my blue one, exactly the shape that it is, and move it 4 to the left. I'm going to just pick a couple of points that I can see really clearly and move them 4 to the left. And that will get me anchored. So my black one is a half. It has that same stretch factor, x plus 4 squared. Lastly, the last transformation we have is negative 5. So I'm doing my last one now. Y equals a half, x plus 4 squared take away 5. I am moving everything down 5. Take my black function. Every point is moved down 5. 1, 2, 3, 4, 5. And I will draw my function. So I have drawn that function using a series of transformations, and that is my final function, which we knew from grade 10. Using transformations, that means do one step at a time. Graph y equals bracket 3x plus 6 squared. So my thought process is, what is my parent function? My parent function appears to be x squared, a quadratic. So I'm going to start by drawing my parent function again. I've drawn my parent function, y equals x squared, and now I want to know what my various transformations are. And I'm going to work it order left to right. I notice that there is no multiplication number right there, and there is no add-on at the end. There are no vertical changes. They're all going to be horizontal in nature. I also see a glaring problem inside the function that I don't have an x plus a number. I have 3x plus a number, and that's not what we look for transformations. So I'm going to write my function out, seeing it like I am used to seeing it, with 3, factoring out the 3, x plus 2 squared. I've got x plus a number. Now I know how far it goes to the left or to the right. My changes are, in order, horizontal compression, sorry, almost got me, horizontal compression factor 1/3. And a horizontal translation 2 to the left. I do it in order left to right. I'm going to compress that thing horizontally first. That means it doesn't go out as far in the wide direction by a factor of 1/3. I know my normal step pattern is over 1, up 1. So I'm going to go over 1/3 up 1. So from 0, 0, because I haven't moved any left or right yet, I go over 1/3 up 1. Instead of over 2 up 4, which I missed by a little bit, over 2 up 4, I'm going to go over 2/3 up 4. It's interesting that a horizontal compression, where we push a function in towards the y line, looks very much like a vertical stretch. It's made it skinny. I'm going to do the same on the other side because those points would all be the same. Instead of over 3 up 9, I go over 1 up 9. So there will be my tall, skinny parabola. So my green transformation is only dealing with the 3. I've taken my parent function and compressed it horizontally by a factor of 1/3 and drawn it. My last one will be where I put the other bit with it, where I take everything and move it to the left 2. I take the points that are easy to see. I'm going to take my vertex and move it to the left 2. The points 1, 9 and minus 1, 9 were quite easy to see. So I will put that there and that one there. I will draw my tall, skinny parabola with the same shape, and that will be my transformed function. My red function is supposed to have the right shape. It's very hard with the smartboard, but it is from the vertex, which is now 2 to the left, over 1/3 up 1, over 2/3 up 4, and over 1 up 9. And that same shape is our final answer. Y equals 3 in the brackets, x plus 2 bracket, bracket, squared. Or you can write it like they gave it to you originally. It's the same function. For example 5, we have y equals the square root of negative x plus 5. My parent function is y equals the square root of x. So that would be my starting point. I have two transformations, but they are disguised again in this problem. I have a negative sign, and I have an add-on inside the function, so a horizontal translation. However, I don't want to know what negative x plus a number is. I want to know what x plus a number is. So I would rewrite that with the negative sign factored out. Once I have x plus a number, I know whether I go to the left or to the right. So first thought is the parent function. Second thought is does that look as it should? My third thought is, what are my transformations in order left to right? The first is a negative sign inside the function, so that will be a horizontal reflection. Horizontal means left to right, right to left, so it is across or in the y-axis. The second transformation, now that I have it clearly in front of me, is a horizontal translation. 5 to the direction? Left. Let's try. Our parent function is a square root function. Starts at 0, 0. Can't take a square root of a negative number. Over 1, up 1. Over 4, up 2. It's the opposite of a parabola. Over 9, up 3. And that is our parent function. First transformation is a horizontal reflection across the y-axis. Rights are lefts and lefts are right. So we have it going in exactly the opposite direction. So you take the negative values of everything. 1, 2, y equals negative square root of x. Sorry, put the negative in the wrong spot. Last transformation is moving that blue function entirely 5 to the left. 1, 2, 3, 4, 5. Our starting point is there. Over 1, up 1 is another significant point. 4, 2. And I have my parent function flipped across the y-axis, moved entirely to the left. 5. That is our final function. You can write it as we rewrote it, which I like, or you can leave it like they gave it to you originally. Example number 6, we're starting with a quadratic with our parent function. We're going to sketch y equals negative f at 2, bracket x minus 5, bracket, plus 6. We don't like function notation particularly, but it is very clear as to what transformations are going on. We will write the final equation when we're all done. So this is our parent function, y equals x squared. We like parabolas. We have 4 different transformations that are going on. Let's list in order left to right. The first is a negative sign outside of the function. That is a vertical. Negative means reflection. And if you're changing you're reflecting, in a vertical sense, you're changing your ups to downs and your downs to ups. So it is a reflection in the x-axis. The second thing that I see is a 2 within the function. So that is a horizontal change. It is a multiplication, so it is a stretch. Because it is a 2, horizontally, it's a compression. Factor 1/2. Notice I've done a couple of horizontal compressions because students hate those the most, and I thought you should be watching them. The subtract 5 is inside the function, so it is a horizontal translation. It is 5 to the right. Lastly, we have an add 6 on the end, outside of the function. It is a vertical translation up 6. Let's draw our parent function and then each transformation in order. Our parent function, parabola, y equals x squared. Our first transformation is a vertical reflection in the x-axis. That means that everything up is down And downs are up. We don't have any downs. So everything that goes upwards goes downward. We are anchored or an invariant point on the x-axis. So this vertex is invariant. It stays glued. But everything above it goes below it. So if we reflect everything downwards, we have the green function, which we see below. We could write that as y equals, because it is, there we are, a vertical reflection. That means the negative sign is outside of our parent function. We would write it as negative x squared. The next transformation that we're going to draw is a horizontal compression factor 1/2. So for our horizontal changes, instead of our usual step pattern, over 1, down 1 in this case, it's going to be over 1/2 down 1. So we haven't moved left or right yet. We stay at that vertex. Horizontal compression means change your overs by a factor of 1/2. Over 1/2 down 1. Instead of over 2 down 4, it's going to be over 1 down 4. Instead of over 3 down 9, it's going to be over 1.5 down 9. So our blue function is horizontal compression, factor 1/2. And I would write that as y equals negative on the outside. Horizontal compression means it's inside the function. 1/2 means there was a 2 involved. We want to draw the third one right now, which is going to be red, which is going to be a horizontal translation 5 to the right. So we take that blue function exactly the way it is and move everything to the right 5. Anchored. And we have our translated function. It's really hard to get those curves straight. I'm really sorry about that. There we are. We're almost done. We have negative. We have horizontal compression, and at the same time, we have 5 to the right. I would write it like they have. Like that. Our last one is a vertical translation up 6. We take that entire red function and move everything up 6. That's not so bad. 1, 2, 3, 4, 5, 6. There is our new vertex. Over 1/2, down 1. Over 1, down 4. And we have our new function. Y equals negative 2 x minus 5 squared plus 6. Example number 7 and last, thank goodness, we have a lot of English, so we're going to translate it into math. The graph of y equals the square root of x is expanded vertically by a factor of 5, reflected in the x-axis, translated 6 units to the right, and 3 units downwards. So we have 3 different things going on. We are going to do a quick check and make sure it follows in the order that we are used to working left to right. I would do an equation first. Y equals. The first thing they suggest is that we expand it vertically by a factor of 5. Yes, that is usually the first thing that we see working left to right. So my 5 goes outside of the parent function. I'm going to have her reflected in the x-axis is a vertical change because I'm moving my ups to downs and downs to ups. A reflection comes from having a negative sign, and since it's a negative in the vertical, it will go outside of the parent function. I am translating the 6 units to the right, which is a horizontal change, so that's going to go inside the function. 6 units to the right, backwards always, is going to be x. Take away 6. And lastly, we have a translation 3 units downward, which is vertical, outside of the parent function. It's going to be subtract 3. I found it more comfortable to try and graph this thing by seeing the equation first from the English, and we'll draw the transformations. We're going to start with the parent function. Y equals the square root of x. Y equals the square root of x is the inside-out parabola. So we start at 0, 0, 1, 1, 4, 2, 9, 3. And on it goes forever. There is our parent function. Y is the square root of x. The first thing that I'm going to do is reflect that across the x-axis, which is the ups are downs and the downs are ups. So I have one that goes underneath. And crooked though it may be, it is a vertical reflection. We are going to change the, got to find this number now, the 5. Here we are, expanded vertically by a factor of 5. So to get the blue function, I would go over 1, down 1 to go from the vertex to this point right here. My verticals are expanded by a factor of 5. That means instead of over 1, down 1, it's over 1, down 5. Starting point is the same. I have to move it up. I hope you can still see. I'm going to do the second one as well. Originally, for the blue one, I would go over 4, down 2. I'm going to go over 4, down 10. So the shape will be the same, it's just much steeper. I have vertically pulled that thing downwards in this particular case. So my new function goes like that. The next thing that I see is inside the function x take away 6. That is a translation to the right 6. So I take my red one and everything is moved to the right 6. Y equals, we have done the negative, we have done the 5, and we have done the 6 to the right. Lastly, I want to move that thing down entirely by 3. We're running out of color. Sorry, that isn't our bell. We run out of color, we're going to go back to green, and we are going to do the subtract 3. That means 3 down. So I'm going to start here. Over 1, down 5. Get myself anchored. It should look the very same shape. Just down. There is our final answer. Y equals negative 5 square root x minus 6. Take away 3. For today and tomorrow, or tomorrow the next day, for Thursday the 12th and Friday the 13th, we will be working on pages 70, 4 to 13, 15, 18, 19, 21, 23. Course notes as well. I need to check those, and I'll put those on the website as well for you, but you've got 2 days to work on those. There might be a little surprise quiz Friday's class.